Numbers can be written in different forms. What we're going to focus on today real quick is taking a exponential expression and turning it into something that's logarithmic, or turning it from logarithmic to exponential. There's various reasons why you would want to do this that we'll explore later, but today it's just about the technique. So writing something in exponential form. Take this expression, for example, or this equation. You're saying base A to some power yields the value of y. This is what we call exponential form because you have an expression or an equation written as an exponent. And we can turn this into logarithmic form by saying the log of the base, right? So log of the base results in the value of y when raised to this power. And so what we do is we have these little arrows going both directions like this, showing an equivalent statement. All that means is that I can write this expression as a logarithm or a logarithm going backwards. All right, so when we add the word log, again, it has some uses in our calculator as well. But for right now, when you add this word log, it's just to be able to write a new form. All right, log of the base raised to the power equals this expression. All right, and so when I see it this way, I know that these two are my bases. All right, this is the final value of what happens when I raise a number to a power, and this is always my power. So let's just look at trying to write some expressions in different logarithmic forms, or vice versa. For example, if I had something and I said log of base 2 that results in 8 is equal to 3, and I want to turn this logarithm into an exponential expression, right? That's the same as saying 2 to the third power equals 8. Right? And so you're not doing any kind of actual evaluating with this. You're just turning one form into the other. Additionally, I could start with, say, a base of 4, and I can write this to the 1/2 power and say that equals 2, and take this expression, and again, I can rewrite that as a logarithm, right, by saying log of base 4, right, results in a value of 2 when the exponent is equal to 1/2. Right? So again, these are just transforming from one form to the other. If I want to evaluate, right, now evaluating is actually taking a format from logarithm and writing it as an exponential and actually finding this value off to the right. So usually it's not written as the full format. It's written something like this. So say log of base 3, and it's going to result in a value of 27. And what I'm doing is I'm asking myself what would need to go on the other side of the equal sign to make that happen. So usually when you see something like this, you're going to put your own parentheses in, and you're going to give yourself a variable, so that way you could then rewrite what you have in exponential form and actually do the evaluation. So then I can say 3 to what power is going to result in a value of 27, and then I can say the value would be 3. All right, so usually this is kind of what you do. You kind of go off to the side, but when your final answer really should just look like the original with the value of 3 on the other side, saying that this is my true statement. Right? So I started off with something that was just log base 3 of 27, and I added this extra piece on here to help myself visually set up what I'm missing. Right? Same thing if I had log and I put 1,000, and I just do this. So now if you do not have a number written as a base, you don't see anything, it's automatically assumed to be base 10. So if you don't see anything, this right here is the same as writing log of base 10, and that's going to result in 100. So these two are equivalent statements. All right, but usually because we live in a base 10 system, meaning everything is place value wise, tenths, hundredths, thousandths, 10,000ths, we don't write that. Right? So if I were to start off with this log of 1,000 and give myself a variable, then again I want to change this into exponential, and I want to see 10 to some power gives me 1,000. And the nice thing about working with base 10 is your power tells you how many zeros you should have total. So if I have 3 zeros on my 1,000, then that means the value I would need to raise 10 to is going to be 3. So again, my final answer would be log of base 10 that results in 1,000 would be the value of 3. Your numbers do not only have to be integer values. They could also be fractions. For example, log base 2 that results in 1/16. All right, so if I put a fraction here, again, I'm going to go and add in my variable, rewrite this in exponential form. So 2 to some power equals 1/16. And now you have to remember a rule of exponents. And so a rule of exponents we talked about at the beginning of the year is that if you have a base to a negative power, then that puts the base to a positive power in the denominator. And so when you have a fraction like this, you really are thinking about kind of going off to the side here, thinking about 2 to what power is 16, and then putting that value up in the top to make my exponent the same. Right. So if I think about taking powers of 2, then that means that the value that I would need for x to be 2 to the 4th power is 16. And so since it's in the denominator, I need to make it to the negative 4th power. Right? And you can check that if I kind of come off to the side and apply this rule. Right? 2 to the negative 4th power means that the base is on the wrong side of the fraction bar. And so I would put that down in the denominator and then evaluate, and I'd get 1/16. So this is just me checking to see that I did it right. But again, my final answer, the way I need to write this, looks like this. All right, and so that's just turning logarithms into exponential form, or again, vice versa. What we're focusing on mostly today is just taking a logarithm, turning it into something exponential to be able to rewrite the logarithm in complete form.